This is a production of Cornell University.
Well, it is really a big honor for me to be given an opportunity to visit Cornell. Of course, Cornell, we give this university high regard in the Philippines, especially there in our university, and share to you what we have been doing in the Philippines. And I was also thankful to Dr. Matson because of being patient on how we can get through this scholarship, this fellowship during the COVID. And now that I'm here, I'm so glad to meet his team at the KPL and meet everyone. And of course, share to you today what we have in the Philippines. Well, we have been involved in the promotion of urban agriculture in the Philippines, particularly the technology of hydroponics and aquaponics and greenhouses, urban agriculture, and a controlled environment, controlled agriculture environment. And, you know, in the Philippines, investment and funding is the very big problem. But we try to do whatever we have there, locally available materials, just to have this. So to start with, I want to first talk about myself. I was born in this little island in the Philippines. They call Marinduque. It has 6 towns, and it is situated in the central part of the Philippines. I spent my childhood there. Actually, my childhood is not easy. We are just struggling coconut farming families. But we thank our parents that they taught us how to go through with our lives. And I spent my elementary and high school in this place. I was given an opportunity to go through Central Luzon State University to take a Bachelor of Science in Agricultural Engineering, where I graduated in 1983. And my study is all about rice combines. I also took up Master of Science in Agricultural Engineering, and I graduated in 1999, focusing on the automation of pressurized irrigation systems using soil moisture. Then I pursued my PhD in Agricultural Engineering, completing it by 2008, focusing on water management systems for hydroponic honeydew gardens. Later, I was sent to University of Arizona in Luzon, and I completed a 6-month scholarship program under Fulbright in 2012. And my study is all about the integration of freshwater prawn in aquaponic systems for tilapia, lettuce, pak choy, and cabbage culture. And right now, I am here at Cornell with this advanced research and university lecturing program under Fulbright. And I am focusing on the study on the effect of pH on the growth and yield and quality of cannabinoid on hemp with Dr. Matson. After graduation, I went to the Middle East for 6 years. I became an agricultural engineer, landscaping engineer, irrigation engineer, doing everything there in the desert. We are installing and maintaining drip irrigation systems, sprinklers in greenhouses and open field for the Arabs. And I was also involved in the establishment of modern farms and water management for pressurized irrigation systems in the Sultanate of Oman, when the Sultan had given lands to the Omanis. So our company participated a lot in those programs. When I settled in the Philippines for good, I started as a substitute teacher, high school teacher at Central Luzon State University. And I persevered until I became a professor at the Department of Agricultural and Biosystems Engineering, College of Engineering in that university. I teach agricultural and biosystems engineering subjects. And one of the subjects that I love is all about advanced techniques to crop growth and culture, which focuses on the things that I love to do all about hydroponics, aquaponics, and controlled agriculture environment. So later that when the COVID hit the Philippines, the Secretary of Agriculture called some of the researchers in Philippine universities, and I was one of those. And I was instructed to lead the Urban Farming Innovation Center, wherein we are promoting urban agriculture with innovative technologies, and we establish demonstration farms, especially in Metro Manila and other big cities in the Philippines. We also assist and provide suggestions in the policy making and implementation of urban agriculture in the country. So Central Luzon State University is located there in the central part of Luzon. So it is about 150, about 4 hours drive from Metro Manila, the capital city of the Philippines. So the early developments in CLSU is when I have this design of automatic irrigation controllers for low-cost, using low-cost soil moisture activated controller. And I believe that great ideas started from crude idea. And we started from this. So we employ this in our studies and research in the orchard of the university. Later, I was called by our university to lead the establishment of a demonstration farm using the Israeli greenhouses and technologies for the production of honeydew melon. And we do that in the soil. We are not yet doing that in soilless culture. But we were able to produce superior quality of honeydew melon. And they love it. Later, I pursued my PhD and I focused on the hydroponic honeydew melon, on water management of hydroponic honeydew melon. And this is my study. As you can see in the pictures, we do not have such systems that you have here. So we have to invent our own system using the locally available materials that we have. And later, I was sent by Fulbright to University of Arizona, wherein I have this integration of prawn with tilapia and vegetables in aquaponic systems. And it is actually, the result of this is available online, published under the scholarship publishing house in German. And here you can see my faculty professor, Dr. Kevin Fitzsimmons, and all those prawns that we have grown in this system. The prawn is situated under the raft system, not with the tilapia. So while in the University of Arizona, I also involved myself in the production of tomatoes, mushrooms, and controlled environment agriculture. And I got a lot of knowledge about what they are doing there in Biosphere 2 and in the lunar greenhouses. So I attended lectures on how they do this, which probably I can use when I go back to the Philippines. Now, this is my report. This is what I'm going to share. So there are many publications that tells that scientists all over the world agree that today's agricultural production systems are not anymore suitable for the new food security challenges of our century. That if prevailing farming systems cannot meet the food requirements of the growing population. In the first here in this diagram, you can see an area in orange bounded by the red and green. And since 2010 to 2050, that area is increasing. That means that the food requirement of the population is increasing. And probably, according to scientists, by 2030, which is 7 years from now, in many parts of the world, there will be severe hunger, which would result to chaos. And that would threaten the peace on our in the globe. In the Philippines, despite the advances that we have in modern agriculture, that is from farm mechanization that the government is pursuing, to protected cultivation, onto plant genetics, food production, especially in our country, remains at the mercy of the changing climate, subject to various destructive elements of natural and man-made disasters. And there are other serious interrelated problems like overpopulation, urban migration, and the aging farmers, and of course, corruption, because we are popular with corruption. So based on the United Nations projection, as of today, we will have a population of 117 million, more than that. And it is scattered in only 300,000 square kilometers. If you are going to study that, that is 6 times greater than the population of New York. Actually, we are ranking about 1.4. We are 1.46% of the total world population, ranking number 13 in the world. That's a small country. And the population density is about 394 people per square kilometers. In Metro Manila alone, that colored area there, composed of several small cities. We are the fourth world's most crowded city. And talking of the city of Manila, this one, it is the most densely populated city in the world. This is one of the big problems that we have in cities. And also, because of this, people want to go to the cities, to urban areas. They live on the countryside. They do not want to be farmers. In 2015, it is about 51.2%. And the rural population is about 48.8%. By 2020, it had increased to 54%. So leaving the old farmers in the local communities to work on the farms. And the average age of Filipino farmers now is between 57 to 60. Just imagine that age will be working in the farm. So there will be a critical shortage of farm workers within 15 years, and actually it's happening now. And our youth love to stay in the city, doing the computers. They don't want to till the soil anymore. And also the impact of climate change in our country. The Philippine agriculture is sick. We have accepted that, and dying. Its contribution to the country's GDP has dropped and continues to decline over the years. Vegetable industry alone is almost in comatose condition because every year we are devastated by so many natural disasters, especially typhoons. And farmers' financial condition continues to worsen, their dignity crushed and devastated. That is why farmers found farming not profitable anymore and as an attractive business. So they were forced to sell their lands to business. Just lately, a big typhoon, destructive typhoon, has passed through the Philippines, and the regions in the northern part of the Philippines were devastated. Rice, for example, that's why we are an agricultural country, but we are one of the highest ranking importer of rice because we are a rice eating country. So because of this, when I arrived from Luzon, from Arizona, I thought it is it is but proper for me to utilize what we have learned. So I submitted proposals to the government, particularly in the Department of Science and Technology, and I was awarded of 6 projects from 2012 to 2022. And we were able to develop this demo farm. And from this demo farm, that has become a center of a promotion of modern technology in the Philippines. Of course, what we have there is not similar to your high-tech here, high-tech technology, but this is a proof that we Filipino can do it, even in our own small way, using locally available materials and our ingenuity. We were able to produce some researches and result of this, and one of them is about tomatoes. We grow beefsteak and cherry tomatoes. And the technology has been shared to many people, especially those in commercial level. This sample, this setup is scalable, and we can even improve this because this is our prototype. Using our locally available materials, especially nutrient solution, which has become the biggest problem in the hydroponic industry in the Philippines. So we try to produce our own hydroponic system. We formulate our own and share this to the government and have it available at low price. So the systems that we have are scalable from commercial to backyard. This is our backyard systems. So we can grow here leafy vegetables and herbs. And probably you will see how these plants can grow in this system because of the sunrise will not be available to all the levels. But you know, we first harvest on the top, and every harvest we promote everyone, and we start from the bottom again. So that's how we do that. Some it will include labors, but you know, just to maximize the space and the investment. And it was there will be a smaller version of this we call household model. So it's smaller, but it depends, you know, because the capacity of our investors is limited. And also we have this 1 square meter garden, which can be established in condominiums and small areas, even in our roof decks. And also we use this for as a system for aquaponic system, 1 square meter garden. We also use the discarded fruit boxes as to contain nutrient solution and plant their lettuces like this. And this is our system that we use for tomato production. And somehow we were able to do some research about this. Of course, we can improve this. And this, we always tell to our farmers, to our investors that there's a lot of things that needs to be improved, but we can start on what we have learned. We also grew cucumbers, different types of cucumbers, and we have done some harvest. What is good here is that we are not only producing more, but we are producing safer, cleaner, and fresher vegetables. So the nutrient solution that were discarded are not thrown to waste. We use that to fertilize our open field crops, like dragon fruit. Our dragon fruit is so sweet because we utilize the discarded fertilizer from our hydroponic systems. And we also grew swamp cabbage from grown in gravel culture using aquaponic systems. And also some researches conducted in aquaponic system for insulin plant production. Our university is introducing this herbal medicine. So I told them that there is a safer way to do this. And one of this is to do that aquaponically rather than planting in soil. We also Dr. Neil, you know, we constructed a vertical indoor farming system there. We fabricated this out of our locally available materials, and we grew these tomatoes and other leafy vegetables and herbs we also try to grow strawberry. Now, when the COVID-19 pandemic happened, the agriculture in the Philippines really suffered. And this pandemic have revealed the fragility of our food systems. Lockdowns and checkpoints made food distribution and delivery difficult to impossible. For some time, maybe 1 month or some weeks, our country was paralyzed because we do not know what to do. And many of our countrymen suffered from hunger and poverty because no one is allowed to move. Our health and livelihood, and of course, the economy was greatly devastated. This is what happened in the Philippines before. We have so much production in the countryside that should be brought to the cities, but there is no movement. Delivery is prohibited. And so that's why most of the produce are just thrown, sometimes fed to livestock. So because of this, the Philippine government somehow give assistance to our people. But there are also those agencies, private agencies and organizations who help the communities, which we call the bayanihan. We call this bayanihan or cooperation. It is a spirit that was relived during the pandemic, which is all about the community pantries and donations from people, which somehow relieve our problems during those times. So one of the government intervention is to produce more vegetables, produce more food. And so when the new secretary came in the person of Dr. William Dar, he made this proposal, plant. And this is all about urban agriculture, because the urban areas was totally devastated during those times. And it encouraged the Filipino to go back to farming and to maximize the use and productivity of every land, resources, and space. He is encouraging us to have a new thinking for agriculture, and that is to apply modern technology. Later, a House bill was approved that talks about the Integrated Urban Agriculture Act, and that is all about the creation of the urban agriculture. And that leads to the creation of the center, which we call the Urban Farming Innovation and Learning Center. I was called to lead this program, to lead this center, and we have done a lot of campaign all over the country. And we have this 5-point agenda just to unify and harmonize the activities of the Department of Agriculture. And it called the people to be involved in food production. And this is one of our setups that we are introducing. This is an aquaponic system. And we grew tilapia, which is our favorite, and we grow a lot of lettuce in this system. Of course, this is just a small, maybe this is just 4 by 6 square meters, but we can scale this one according to the financial capability of farmer. Also, we try to involve the people, the urban dwellers to be involved. So all those people that are living in urban areas, we encourage them to produce and use all the spaces, even in their roof deck. Those people involved in tourism, we help them so that all those who will have vacation in their area will not only enjoy the scenery that they have there, but will also learn how to produce food. And all those people in the academy, we try to introduce using their roof deck of their universities. And one of them introduced this crops in the sky or crops in the rooftop like that, utilizing all the spaces in the city. And this one is one of our participants. Doesn't have space in their area, so we use the rooftop, and the production is really very improved, very much improved, and they love it. And once the neighborhood learned about this one, they were all encouraged to do the same. So this is some of our projects. We only use PVC pipes because we do not have that rectangular pipes that you have here. And so somehow we produce these different types of vegetables. Also, some of our clients try to duplicate what we have there in our research area, and he wants to try this controlled environment using this fabricated chamber. So the Philippines actually need help. And that is why I told Dr. Manson that if somehow we can have some collaboration with our universities, because the target now is the youth. All those people in the academy must call those students to learn more about food production. And it must be included in their curriculum. And so if we could have collaboration and share what you have here in Cornell, probably it would be a great help to our people. And in conclusion, urban farming, actually, we have found out is a viable strategy, augmenting the food requirements in urban and rural areas, and utilizing modern agriculture, like smart and precision agriculture, could enhance food production that would utilize the limited resources like water, space, and energy. And policymakers should legislate laws to involve the youth, because they will be the one who will suffer if they will not in the future. Telling them that food security is not only the concern of the government, of the professors, but it is our concern. All of us is concerned. So we are encouraged to plant. No stopping to plant. As a challenge, our secretary is always telling this to us, that no pandemic can bury our dreams and aspirations, that no lockdowns can slow us down. So let us turn challenges into opportunities to survive and move forward towards a food secure and resilient Philippines with prosperous farmers and fishers. And so we were all encouraged, and somehow the Filipino people have now new thinking for agriculture because of his presence before us, Secretary. And from here, I would like to thank you very much for listening.
We have some time for questions. John?
Chito, I have a lot of questions.
Yes, sir.
I'm going to start, or actually just give you one. From a participation perspective, how much participation are you seeing recently from the sort of growth in urban agriculture?
The participation of our group, sir?
Of the general population.
Oh, okay.
People in the city. I mean, how quickly is this growing and where's it going?
Oh, before, when we introduced this hydroponics and aquaponics, people are telling that this is a stupid technology, especially for a country like the Philippines, wherein we are totally agriculture country. But later, just informing them the importance of this and the relevance of the benefits of this. Later, after 10 years, many have participated, not only in the urban communities, but also in rural areas. And I would suggest from year one that we started this, we are probably about 6, from 1 to 10, we are about on level 6 of acceptance and interest. And somehow with the program of the government, I think we have helped them in
So
introducing.
it's not a bunch of crazy scientists anymore.
Not
So they're accepting of it. How's it going from there?
From there, our government is pursuing this urban agriculture, and a House bill is approved in the lower house, and it is the Senate now is creating a joint a bicameral committee on this, talking on this, and actually the first thing that they are doing is to include this in the curriculum, because it is the youth that needs this to learn these things.
So this is gonna be reaching down into like elementary school, high school?
Yes, sir.
Yeah.
Yes, sir. Because from the elementary school, the love of tilling the soil or growing food like this
Yeah.
must be taught. Yes, ma'am.
I was just as I was watching your talk and thinking about the beautiful agriculture in the Philippines and all the history of rice cultivation and biodiversity of rice cultivars, I was wondering that as the government wants to industrialize the agricultural system, are they thinking of safeguards or implementing strategies to retain that diversity? Because that seems like it's a very climate smart thing to do, rather than just going to monoculture, which often happens in industrialization.
We have in the Philippines the International Rice Research Institute. And we also have a Philippine version of that, which we call the Philippine Rice Institute, or the PhilRice, which try to improve our varieties. And before, let's say 20 years ago, the average harvest of rice per hectare is only about 75 kavans. This is about 50 kilograms in one sack like that. But today, our farmers know, because of the influence of these two institutes, the improvement of the varieties, we are now growing about 200 kavans per hectare. Of course, land area is reduced because of, as we grow the population, and also the urban, because of the industries, we are losing several hectares of land every year. But with that increase in harvest, because of the improvement of rice varieties we have. And also, the only problem that we have there is the climate. No matter how good our production systems here, we do not have full control of the. Somehow they are trying to improve the varieties, having this resistance to wind, resistance to drought, and submergence to water.
Son should come in on chat. Let's take this one first and then go to Zoom.
You mentioned that, like when setting up control environments, often use a modified part, like pipes, stuff like that. So have there been any challenges with like how to set up infrastructure, or most functions the same pipes like the traditional?
Using this low-tech technology, we have somehow improved the production. And there are several studies on comparing this in the traditional system. We have improved the production because you can do this everywhere, even in the cities. I just don't know whether I answered you correct. And the intervention of the city government is really very great, because there in the city, especially in Metro Manila, they are employing this incentive that if there is a vacant lot in an area, or let's say in a subdivision, you can utilize that, and the owner of that lot will be exempted to taxes. And so a lot of people in the community, utilize those technique, and the owner of those lands actually, or those lots, are actually like that idea, rather than keeping it very dirty and weeds will grow there, and it's very not nice to look at, especially in the city.
There was a question that came in on the Zoom chat. Paul writes, hello, thank you for sharing your experience. Could you please let me know how to split the cost of hydroponic equipment? The participant pay for the equipment, who manages the technical stuff such as the nutrient solution, and then do you teach them how to manage the crops? Okay, right. So there's the expenses involved. And
Yes. In the Philippines, the investors are really afraid to invest because, so we have to cut the cost of establishment. That's why we utilize everything what is there in the locality, especially the substrate. Here you use different types. Rock wool, the expanded clay, and we are going to import that in the Philippines. So we use what is locally available, like gravel, like volcanic cinder, like lahar. We have a lot of lahar in the Philippines because of the Pinatubo eruption. You remember that one? And because we are a rice producing country, we utilize rice hull and carbonized rice hull. And we are also having this waste of coconut, from the coconut. So we have a lot of cocoa coir and cocoa peat to use, rather than importing them. Now, for the cost of establishment of greenhouse, we try to simplify the greenhouse, but taking into consideration the impact of typhoons that we have. So far, our design is good enough to withstand the signal number 3 that we have, about less than 200 kilometers per hour wind. So we can still manage to get that one. So what we have there is we usually share what we know, everything, just to help our farmers. And from the establishment of the greenhouse, on how to prepare the seeds, even to the growing, the maintenance of the nutrient solution, we do that in seminars. Now, in fact, there are so many available materials that was recorded by the Department of Agriculture and the Department of Science and Technology, available online for them. You just click CLSU, Chito Sace, find it in Google about hydroponics and aquaponics. It's there, and it is available. I also have some publications for some of these technologies, which are available free online. So that is how we could help. And we have our team in Central Luzon State University that when you request from our university president, we can send even in the farthest place in the Philippines, just to help extend what we have known and share to them whatever they need.
At the beginning of your presentation, you mentioned problems of corruption. Has that affected your efforts at all?
Yes, of course.
Right.
This sounds funny, but I just years ago, we are about number 3 in Asia about corruption. 2 or 3 years later, we are number 1. And this is what is happening. One of these people in those countries tell that corruption in their country is always done under the table. And another country, oh, that's nothing. Corruption in our country happens, on top of the table. But in the Philippines, it's different. We include the table in the Philippines. That is how bad. I hope it would be corrected. Actually, we are just laughing at this, but corruption is everywhere, but probably worse in our country. Yes, sir.
I'm curious if there's vegetables like native to the Philippines or that the population uses that we're not maybe aware of in the US, but you're finding like success growing them in the Philippines.
Yes, sir. We can do some research about that, about introducing some of our. That is how. That is why some of our university, my friends there, wanted to make collaboration with Cornell. We really love to learn from you. We really need more knowledge how to improve our systems there. Yes, sir.
Wonder how much climate control you have in those farms.
Oh, we usually do what we call tropical greenhouse. Tropical means whatever in the surroundings, we will utilize that just to grow food. So I usually discourage them to introduce fans to cool them. And what we have is only a motor and a system we call passive system just to cool the nutrient solution. We do not use any cooling systems. And just to limit the cost of energy and the investment into it. So we tropicalize the system. Of course, it is the growth is affected, but somehow we can grow. Number one, there is the devastation of insects. So inside the greenhouse, of course, we will not spray, especially for short duration crops like leafy vegetables. We try to limit the investment.
Structure that you have to handle.
Oh yeah. So far our structure, it is just made of galvanized iron pipes, and it is fully welded and strongly connected to the ground. So, and we do some bracing just not to allow water during typhoons, heavy downfall, to go inside and affect our crops, and of course the strong wind. Somehow we were successful in doing those structures.
You said they were good through category 3.
Yes, it is about 200 kilometers per hour, something like that. Very strong. If you know a coconut tree, it would bend to about 50 to 45 degrees like that. It's signal number 3. You can see a bamboo that would bend like that, signal number. And we somehow managed to have those structures still.
All right. Let's hold it, stop questions there and thank Dr. Sace.
Thank you very much. And of course to my host professor and also to Cornell and to all of you. Thank you.
This has been a production of Cornell University, on the web at cornell.edu.